Welcome to the first lecture of grade 11 chemistry. I want to keep hammering this drum about communication. One of the main things you can do is ask when you have questions, so please get in touch with me if you have questions. Let's start into what we're talking about in chemistry. Okay, so in this block here is every single element that's in our universe. So everything you see around you, solids, liquids, gases, everything, if you look into the stars, this is all the elements that we know about. Now, there are elements on Earth that are nowhere else in our universe because they've been artificially made. When I was in high school, I believe there were 96 elements, and now we're up to about 118 elements. All of these elements are made of things called subatomic particles. So protons, neutrons, and electrons are what's important if we're going to talk about chemistry. Now we can go way smaller. We can go into muons, gluons, quarks, leptons. There are things that make up protons, neutrons, and electrons, but we won't be covering those. The main thing in chemistry is going to be electrons because those are what's involved in bonding. So in particular, it's going to be what's called the valence electrons, and we'll describe those later. Sizes. Chemists call a proton the size of 1 and a neutron the size of 1. In actuality, the neutron is ever so slightly bigger than a neutron is ever so slightly bigger than a proton, but just barely. An electron is 0. Nothing is actually a 0, but relative to a proton and neutron it is. An electron is 1/1837th the size of the proton and neutron. That 1, 1, and 0 is going to be important. Location. Protons are in the nucleus. Neutrons are in the nucleus. And electrons are in orbit around the nucleus. Try to work on your visualization skills as you go through this course. So to try and imagine what things look like can be important. Charges. We've got a positive charge and a negative charge and no charge. So if I can just very quickly draw a caricature sketch of what helium looks like, it would have 2 protons and 2 neutrons in the nucleus, and it would have 2 electrons in orbit, and these electrons are moving at the speed of light, which is fast enough to get around the Earth several times in 1 second. Okay, it is hard to visualize exactly what an atom looks like, but this is a cartoon representation right here. So moving forward, important thing, protons, neutrons, and electrons are what we're going to be studying. In particular, we're going to be focusing on electrons in this course. Now, I'm going to give you a periodic table, so I will be emailing this out to you, and you're going to see 2 important numbers. Well, there's many important numbers, but 2 to start out with. The atomic number is 11, and the atomic mass is 22.9 for sodium. So there's where we get our atomic number, and there's where we get our atomic mass. So what is this atomic number? The atomic number is its place on the periodic table. It's the 11th element on the periodic table. And it also tells you how many protons it has. I'm going to emphasize something very important. This is a short form for protons, P+, is that the 11 tells you how many protons you have. Therefore, if you have a neutral atom, you have the same number of negative charges, which is the number of electrons you have. So this is the atomic number. This is the atomic mass, or mass weight, right here, the 22.9. Now, if every proton and every neutron has a size of 1, this tells you how many protons and neutrons are in the nucleus. So this tells us the number of protons and neutrons in the nucleus. Folks, just a disclaimer I'm going to give. Watch videos a couple of times. Go back over them. Okay, you can't rewind a teacher, but you can go back over the information that's in here. Another thing I would highly suggest is that you do active listening. That means to have a pen and paper handy and you're making notes as you go. What are we going to do with this information? First of all, we round this. Now, the reason that we have this number here, you would think, well, it's got to be a whole number. It's got to be 1, 2, or 3. It's because the reason we have a decimal is because some sodiums have 22 neutrons, but most sodiums have 23 neutrons. So this is sort of like taking the average. So always round this number, put it here. Always take your atomic number and put it there. I said that this tells us that we have 11 protons and therefore 11 electrons. If we subtract these two, because I said this is the total number of particles in the nucleus, if we know 11 of them are protons, 23 minus 11 is 12 neutrons. So far this morning, this is the most important thing that we've done right here. You need to be able to figure out how many protons, neutrons, and electrons, and we're going to use this information later on to do some drawings. Let's try this with chlorine. I drew the information the way you would see it in your periodic table. I am now going to round. Oh, that says 34.5, so I'm going to round it up to 35. If you rounded in the wrong direction, I would not take marks off on a test, but you've got to round that number. So that's 17 protons, 17 electrons, 35 minus 17 is 18 neutrons. Get in the habit of doing things systematically so that it becomes automatic later on. Okay. What happens if we have a charge on something? Let's try two things. We'll do magnesium and we'll do oxygen. So if I look up the data on magnesium, I'm going to have 24 and I'm going to have 12. For oxygen, I'm going to have 16 and 8. And now we're going to give a charge. We're going to have 2 plus, and for oxygen, we're going to have 2 minus. So do everything as if there was no charge. Okay, it's very important. This is the only number we can change here. The 2 plus means we've got more pluses than we have negatives, so we must have 10 electrons. Okay, the reason we have a 2 plus charge is because we've got more positives than we do negatives. We've got 12 positives, 10 negatives. So to figure out the charge, look at the charge, change your electron number. We can't change our proton number. Okay, so for a negative charge, we look at our charges. We have 8 pluses here and we have 8 negatives, but we have a 2 minus charge. We need more negatives than positives. So I'm going to change this to 10 negative. Okay, I'm going to give you one to try. We have sodium. And sodium is 1 plus. Take 1 second and see if you can figure out how many protons and electrons we're going to have. Remember that plus means we need more of the positive than the negative, but we can't change the positive. We can only change the negative. Take a few seconds, see if you can figure this out. Okay, so we need 1 more plus than we have negatives. We can't change the positives. We can only change the negatives. Folks, this will get us through to the first worksheet that you have to do. I will assign you some questions and then you guys can go to it. Remember, take notes as you go through. Keep these notes and also watch videos a couple of times to make sure you get the hang of things.